Hi students, in this video we're going to look at fractional indices and surds. Right, so after watching this video you should be able to use root signs to express numbers with a fractional index. You should be able to define surds. You should be able to evaluate numbers that have a fractional index and then apply index laws to simplify expressions that involve fractional indices. Right, some things you have to remember. So our index laws, ones like a to the m times a to the n and a to the m to the power of n. Some of our index laws, what we do with those you will need to remember for this lesson. A few other things to remember, a few other terms. So a rational number is any number that can be expressed as a fraction. So for example, 0.5, which is a half, 0.3 recurring, 1/3. A rational number is any number that can be expressed as a fraction. Even 4 is 4/1. That's still a fraction. Irrational numbers cannot be expressed as a fraction. So the decimal place values, they'll go on and on forever with no repeating pattern. An example of that will be something like pi. And we'll actually go over some more examples in this lesson. Right, fractional indices do not have to be positive or negative whole numbers. Sometimes they can be decimals or fractions as well as 0. So some examples here, we've got 49 to the half or 11 to the third. Those numbers are also perfectly reasonable and accessible numbers as well. But the problem is, well, what does it mean? What does a power of half actually mean? What does a power of a third actually mean? So let's consider 49 to the half. What I'm going to do is apply one of our index laws and square 49 to the half. Now, according to our index laws, what that means I can do is multiply these powers, right? Power to a power means I can multiply. So I've got half times 2, which is just to the power 1, and have an invisible 1 there. Right, rewriting that, 49 to the half squared equals 49. Now what I'm going to do is I want to get rid of this squared value. Now the opposite of squared, we've been taught, is square root. So let's square root this whole thing, and square root this side. The square root there and the power squared cancel each other out. So we're left with 49 to the half equals square root of 49. So power half actually means square root. They mean exactly the same thing. And the same sort of thing is true for 11 to the power of 1/3. 11 to the 1/3 actually equals the cube root of 11. So numbers written with a fractional index can also be expressed with a root sign. So just like our square root or our cube root. So our rule there is a to the 1/m equals the mth root, or the mth root of our value a. Just like 11 to the 1/3 is the cube root of 11. Right, some definitions. So notice that 49 to the half, which we said was square root of 49, that's 7. So 49 to the half is actually a rational number, right? So it's just the number 7. 7 is just 7/1. It's a fraction. It can be a rational number. However, 11/3, or the cube root of 11, is 2.223980090569316, and that's where my calculator stopped. But those decimals will actually go on forever. And looking at these decimal places, there's no pattern. 2 2s in a row, 2 0s, no counting up, counting down. The numbers are all over the place. So that's an irrational number. Right? The cube root of 11 is irrational because those decimal values will go on forever with no repeating pattern. Now, Any irrational numbers that are not written with a root sign, we call those surds. So cube root of 11 is one example. Another one will be cube root of 5. If you type that into your calculator, you'll get decimals that go on forever with no repeating pattern. In the same way, the fifth root of 10, right? What does that actually mean? So the fifth root of 10 is like what number times itself 5 times gives us 10. There's no rational number for that value. So we call this number a surd as well. Something like square root 36 is not a surd because we know the square root of 36 is actually 6. That's a rational number. So square root 36 is not. Alright, so a couple of examples. Let's write the following numbers with root signs. So we've got 3 to the half here. So we just saw that power half actually just means square root. So 3 to the half is just simply square root 3. Now for this next one, we've got 74 to the power of 1/6. So how we write that then is 6th root of 74. Now students, it is important when you write this 6 or this root number on that it's above the tail of our root sign, so that's nice and clear. If you write 6 root 74, that's something very different. So that actually is 6 times square root 74. That's not what we want. So make sure your 6 is little, just like a power, but put it on the tail of your root sign to make sure it's clear what you're looking for. And what this number means is what number times itself 6 times actually equals 74. That's what the 6th root means. What number times itself 6 times gives us 74. But anyway, I digress. That's how you write numbers with root signs looking at those powers. All right, now let's do some more evaluating. We've got 100 to the half. Well, that's the same as square root of 100. And we know the square root of 100 is actually 10. So there's our value for that one. For this next one, we've got 8 to the third. So that's the cube root of 8. So we're asking what number times itself 3 times gives us 8? Well, that's actually just 2. So we can write the cube root of 8. That is 2. 2 times itself 3 times gives us 8. And then finally, let's do some simplifying. So our index rules are exactly the same. So for this first one, when we're multiplying bases, we're just going to add our powers together. The bases are the same, y and y, so we can just add those powers. 2/3 plus 5/3, that'll be y to the 7/3. A pretty easy one to start off with, just again adding our powers. For this second one, we're dividing with the same base, so we can subtract our powers. So we've got 2/3 minus 1/4. Now I might do this one a little bit separately, so let's do 2/3 take 1/4. To get the same denominator, to subtract them, I'll just make them both 12. So for the first one, times top and bottom by 4. For the second one, times top and bottom by 3. So we'll have 8 over 12 minus 3 over 12, which equals 5 over 12. So that means our answer will be x to the power of 5/12 by subtracting those powers. Now last one, we've got d to the 3/4 squared. So how we can write that one, we just multiply our powers together. So that'll be d 3 times 2 gives us 6 over 4. The denominator stays the same, and we can simplify that d to the 3 on 2 by cancelling out, dividing both numbers by 2. All right, and that's how we can simplify expressions with fractional indices. All right, so students, after looking at our notes and examples, you should be able to use root signs to express numbers with fractional indexes. You should be able to define surds, you should be able to evaluate numbers with a fractional index, and you should be able to apply index laws to simplify expressions.